Thank you so much. So I'm Red. I'm behind this amazing project, which is called Celestical. We do with space engineers. I'll tell you more about it while I'm speaking. And I'm going to focus on how to run Python programs on the cloud, including LLMs. Hello. So I prepared an agenda which is quite consequent. So I hope you're ready to listen to all this. Fortunately, they told me like it's less than 3 hours for the talk, so I have to shrink down a bit. So I would just want to start with you guys. So who is using the cloud right now? Yeah, one, two. Oh, that's quite a lot over there, yeah? Who is using the cloud and you don't even know? I guess it's everybody. Huh? So who is actually doing data science? Yeah, models. Yeah, okay, Danko, stop it. That's good. And who? And do you know where you compute? If you compute in the US, raise your hand. Yeah, there's one, that two. Yeah, I guess most of the people don't know, but you compute in the US, even if they say it's in Europe. So the GDPR compliance of 2020, and I guess my colleagues from the European Central Bank knows about that, is that you can't actually compute on somebody else's computer when this somebody's is under US jurisdiction. So that's the problem. And you can't compute European private data on that. So that's why I was driven with my former space colleagues to actually do a cloud. So this is me, Red. I'm the founder of parametry.ai, which is the company, the AI company behind that cloud. I'm PhD in robotics. I worked at the European Space Agency. I also worked at NASA and the SETI Institute. And I also worked with the European Central Bank, one of the best institutions in the world. Yeah, they do machine learning on Dell computers. And better, okay. So do you know your neighbor right now? Or just like quick, just say hi to your neighbor, the neighbor you don't know yet. Yeah. 10 seconds you have to. That's important because then it's a meetup, you need to network, okay? So, all right, so let's get into it. So Parametry, this is my company. We do challenging stuff. We don't like easy, okay? So, and I guess my guy in the back, they know. So we do actually Space DAO. This is a decentralized autonomous organization for space traffic management. So we actually deal with the DoD in the US, all the defense people that are actually sending stuff in space, overcrowding the orbit and actually trying to avoid debris. And they have to negotiate who is moving. We're on the way, like you move, no, I move, no, you move, you move. Oh, all right. Those kind of things, complicated, geopolitics. And the other one is the easy part. So we do AI compute on the ground. My colleagues and I, we were doing AI on satellites, which was hard enough. We put that on the ground so that we are actually 3 times to 10 times faster than AWS. That's why we eat them for breakfast. Love it. But the reality of things is that who does data science and cloud, it's just a little portion of the room. So we actually help companies in doing their AI ops. So we bring their models to the cloud. So we do the DevOps of AI. This is super important, else they're not there. That's the thing. And we do that in IoT, healthcare, and aerospace for now. So running a Python script in the cloud, it's easy. You just have to use one of those clouds. So Celestical, you know it, right? AWS, Azure, GCP, DigitalOcean, whichever you have, you know, OVH, cloud, whatever. So to help you, we actually made containers, which are open source containers. And the license we're using is LGPL, meaning you can integrate it in your own software. It's totally free, like in Freedom, and also in Free Beer. And we have few of them that might interest you. Here's the link to the GitLab account, to the GitLab, repository, where you'll find all those containers. And today I'm just going to show you the simple container, how this works a bit. So you actually go there, there's a code folder where you actually can just put your Python script. I'm breaking down to super simple, you know. A Python script is actually a text file where you put everything you want there. Here's a special one, which is actually running a Streamlit application, meaning it's a little web server. You can click on the button and run something else. It's actually fun. But you don't have to do that. You can just run a script, a scraper of the web, hacking emails of a company, you know, all those things you should not be invited to do. And so we have another container which actually sends email for EDA reports, so data exploratory analysis, like this one. You receive that in your email. So this is one of the other container which is there. You can actually choose which data you want to scrape, the analysis, and then you receive that in your email. And it's run on the cloud, so you don't have to bother with your Dell computer. So now you can, in that script, you can actually run an LLM, okay? This is almost like something, do not do that at home, but you can try. So you can try to use the Hugging Face tool suite and use the Transformers pipeline, and actually that loads the LLM and actually runs it. And I try to do that on my CPU, so which is actually a Dell computer. It's actually 5 to 7 years old, I don't remember, it's like four cores. Very small memory, I have 8 gigabytes here, and I'm crazy. You know, like the operating system I have nothing to do with yours. It's actually just 3 times faster just by nature. And I just want to do that. So for now, you see like some activities which were just loading a few things, and then the analysis of all the codes that happened. So it's kind of a code analysis. And you see here, I have three models that run. Okay, each of them took about 60 seconds to answer 5 times of planning of a birthday plan, a trip plan, or fridge planning. It's more like, that's what I have in the fridge, give me some recipes, I can do that. And that can run on my CPU. You just have to wait, okay? So there's another thing, if you want to run but serve to your colleagues, for instance, which is called VLLM, so virtual LLMs. You can virtualize your LLM. So you kind of give an open API-like API, an open AI API. Yeah, right. So people can actually talk to it as if they were talking to ChatGPT. So, it's true. I love it. Oh, there's something here. The Akkustand ist niedrig. I can finish. I will see the CPU load. So this is how you do it. So you run a VLLM. This is a command lines, okay? So it's you can actually do the same in Python code. This is an interface that you can put on top so that it looks like your own ChatGPT. You can put your own logo, it's your own ChatGPT, and people in your company can just hit up that LLM, which is in-house on your computer. Why am I telling you that when I'm actually providing a cloud? Because I like you to have knowledge to take the best decisions. And I like you actually with this knowledge to understand you don't need a US intermediary, all right? And this is my CPU running full force on running the LLM and the interface, which actually eats up a lot of resources. My memory is totally used. I'm starting to swap. This is getting crazy. Hopefully I have an SSD. But yeah, don't do that at home. So temperature is starting to rise, 55 degrees. I can almost start to cook eggs. And that's the possibilities you have, right? So what are the limits? Of course, the RAM, okay? Each processor can do things. If you can wait, you can do those token analysis very easily. You just have to wait. But RAM is the big limit. The next is the CPU. It's a facilitator. GPUs works thanks to CPUs. So if you don't have a CPU, you don't have GPUs. Of course, your GPU is a savior. If you have a GPU, then you reduce that to 1, 2, 3, 4 seconds, and that's actually wonderful. So the tool I'm talking about today is VLLM. When I went around and talked about that, discovered all the tools. You can see LM deploy, which actually breaks down and use even less resources. And LLM, we're actually trying and deploy on our own cloud so you can have it for you, which is actually breaking down things so it can run on small GPUs, like regular GPUs, your gaming GPU, for instance. So that's it. And behind all this, we have operating systems so that at some point we can tell we're eating AWS for breakfast. We actually love that sentence, that to make everybody understand we are not using the US clouds. Okay, we have our own servers. We are in 4 different countries in Europe. We are in Paris, Amsterdam, Frankfurt, and Helsinki. We're in Helsinki just because it's connected to the Antarctic, and it's actually nice. To the Arctic, yeah, thank you. And in Europe, we have observed we are 3 times to 10 times faster as AWS, but we're starting to make all the benchmarks with Azure and Google Cloud. So reach out to me if you want to know more on those things, because we are currently at the European Space Business Incubator, launching that. By the end of the year, we are rolling out to a lot of users, and for now, we are opening a waiting list. You can join as a beta user. If you have an interesting European use case, just hit me up. Thank you very much. And of course, if I raised questions, this is the moment. If you have questions, if you want to take a selfie of the screen, I'll leave you to it.
Yeah, we have plenty of time for questions.
All right, I love it. Christos, you have a question? Yeah.
Is there a question?
Behind you, Christos, I guess they have a question. So.
Where? I don't see a hand.
I think I have a question like, who is going to the cloud after that talk? who is actually more motivated to go to the cloud after that talk? I love that question.
I have a question. Oh, no, I was first. What was the operating system? This thing that you showed, I've never seen it before. Is it some Linux?
It's Linux, that's for sure. Yeah, it's Linux, but it's not just binary Linux. So a lot of people know about Ubuntu. You take it, you install it, and you close your eyes, and it's there. It's like Windows in the end. But it's actually a source Linux. So if you don't know how a computer works, you can't really install it. So, and you have actually to choose your kernel modules, everything that you need to activate. So meaning that my PC's boot up in 3 seconds. It's a very old one because it doesn't load unnecessary things. So, and all those things, you know, when you start your computer, you're on Windows, you have plenty of graphical stuff. It's using like 4 to 8 gigabytes of RAM. Mine is using 200 megabytes.
I see. Everything's text graphics.
Yeah.
Is that why it's 3 times faster than AWS?
Yeah, that one is why it's like 40% cheaper. Because we have free RAM for you, actually, for your applications.
Okay. Yeah. And what makes it faster? What is faster, 3 times or 7 times? So
yeah, that's a good question. Yeah. So in processors, you have different vectorization functions that actually do things faster. If you don't use them, then you're stuck in the realm of processor-independent code, which is what all those binary distributions are doing. So that's convenient because you can run things everywhere, okay, the same operating system everywhere, but that's very inconvenient because you don't benefit from the processor powers. And in the last 10 years, we have so many things that we actually don't use from those processors. That's why we're just faster, just because we take care of configuring for the processor.
So if I can reformulate that, you're saying you can run LLM on CPU faster than AWS because you're using the special hardware within the CPU that accelerates LLMs.
Exactly.
Okay.
Yeah.
Now I understand it.
Yeah. Right. Also, sometimes it doesn't even work on AWS. We have to retune.
Yeah. Maybe you could give us a few technical secrets how this works. But there was another question. Yeah, please.
I hope I didn't answer already.
Thanks for the talk. I would have a question because you said you beat AWS, and they have some student subscriptions, so educational packs. And do you have something similar for students to try out your solution?
Can you closer? Yeah.
Okay.
They have what?
Do you have any educational pack like AWS for students to try out your solution?
Yeah. I actually tried the AWS education part. So there's a good side of it where you actually learn the open source stack. And then there's the bad side of it, which, a year ago I was trying to recruit cloud architects because I thought that was the name of people who know how to build a cloud. What I found is that people barely know Linux and they know how to click on buttons so that the service goes online, but the buttons of AWS. So you need another certification to click on buttons of Google and those kind of things. So we actually do, at Parametry, we started just recently the Parametry Academy. So we kind of teach you the fundamentals that you actually missed, but that gives you all the possibilities for the rest. So how a computer works, how do you install a system, so you understand the other things. As a data scientist, you understand how to optimize your own software. Because we can do as much on the operating system. If your software is doing wrong loops, then you kind of waste everything. But we do this kind of also like cloud education on how to go to the cloud, but not just our cloud, but any kind of cloud, so containerization. I hope that's what you meant.
Yeah, but I wanted to know if you give any subscription keys or something like that to try it out in practice.
Yeah. We discussed with Pornesh over there. So if you're a student, you have an application which is 1 to 3 containers. We'll actually give it for free, so you can actually try the system. Yeah?
Okay, cool. Yeah. Thank you.
Yeah, hit me up.
I just had a follow-up question.
Yeah, go ahead.
What kind of applications can be deployed with Celestical?
So we are competing directly with AWS Fargate, so meaning that's the serverless world. So it's up to you. And to give you examples, we have different things. We have people doing media content distribution for online courses. We have others, because we're from the space industry, they're actually doing cataloging of all the objects around the Earth. They're also doing collision avoidance calculation on our cloud. Okay. And we have other use cases coming, which are like secure data hosting and resilient data hosting for IoT across intelligence around lakes in Germany, for instance.
Okay.
Yeah. So it's very varied. Like the spectrum is huge.
Thank you.
Yeah, you're welcome. 3 other questions? Oh, here, Danko. Oh, this is.
Hello.
Hello.
My question is, what are your future plans for Celestica?
So our future plans in ahead. So we're trying to play the green card, but not greenwashing. You know, in the sense that we are actually trying to build a whole data center design where the cooling system is directly connected to how the operating system works. So we can know in advance, like little advance, doing nowcasting, how much processing is going to happen on the processor. And the way you do those processing, if you do spikes, you have less energy, less temperature rise than if you do constant processing. And we're trying to link that together. So we have some sort of a smart energy management data center. This hasn't been done yet, and we want to go there. So that's what we're doing. And also we want to push. So we are talking with different providers. They have hardware which is beating NVIDIA-based hardware right now. So that we can actually provide this AI compute in Europe, which is becoming unbeatable and necessary. Thank you. We have first a question here.
I actually thought to ask or not, but then decided to ask. How do you test what you offer? So how does testing look like at all?
So you've seen the profiling that we did. So the table was profiling. So we actually see what are the system calls down to the lowest libraries. We prepare benchmarks, so meaning we containerize our application in exactly the same containers going to run on our cloud, on another cloud, or another. So that's how we ensure we compare the right things. It's still very complicated because from a service to another, they provide 2, 3 vCPUs, and you never know if you're exactly matching. It's super complicated. But yet we're trying to match, and then on our side we can adapt to the matching, and then compare them. Okay, thank you. Over there, Denko.
Thank you. Can you share more on who are your current clients that are using Celestical?
I still have to have agreements to who they are and what they do. But I guess I can clearly speak that there is a company which works for the European Space Agency, which is actually hosting some of the most brilliant flight dynamists in the world. So people actually compute trajectories of satellites. I don't know if you realize the combinatorial problem with that, because when you're in space, it's in 3D, and you're crossing other satellites that are going around. So if you want to compare the traffic to what you know, what's in space, imagine you're in your car, you're running 200 kilometers per hour in a city, you don't have a brake, and there's no road, and everybody's the same. And you have to avoid each other. You'd better know in advance. That's the thing.
Fantastic.
So,
Any more questions?
Hamid.
Thank you. How can you ensure that the big companies like Amazon or Google don't do the same?
That's for sure. They're going to try to do the same. That's for sure. So the unfair advantage that we're trying to play is actually the bottom-up approach. So I'm talking here, you know, like there's a young professional there. We are building a community of people that actually work in different companies that have decisional powers. We're not trying to go top-down with a lobbying approach, which actually I don't really like. I worked at the European Central Bank, where I was the target of this lobbying, where I see people from Microsoft telling you, hey, you know, Microsoft, it's Linux. It's like, you know, you're talking to... So there's plenty of things, you know, even if you talk with people from AWS, you know, you can beat in different ways. The challenge is marketing. Okay, so they have an extreme loud marketing practice. Yet they have 250 services, which is the counter argument, which is good and actually extremely bad, because those services are old services, most of them, and they can't get rid of them. They are kind of stuck. So they have a huge burn rate. So if they need to beat us, it's easier to buy us. So that's the thing. It's make or buy at this point. Yeah.
You are one step forward.
Exactly, at this point, yeah.
Thank you.
Thank you, Armin.
Any more questions? All right, let's thank our speaker one more.